Hey, this is Philip at thebest3d.com, and I wanted to just explore a little bit more on that exporting of the Wavefront OBJ file from the 3D Designer module. So as you can see here, I have a texture that's a fairly small one. It's 256 by 256 as far as an image. And what I did is I created some text in it. There are some items that I saved out of the 3D Designer, and I'll get back to that a little bit later. Let's just move these out of the way here. There you go. So I have this image here that is 256 by 256, so relatively small, but it's a good idea to test that so you can see whether it works with your 3D program, because some 3D programs will have limitations as to how big a mesh they can load, and this one's relatively small, so that should work with quite a number. Then there's the question as to whether it supports the OBJ format that we export, because OBJ can have data in many different formats, in many different structure or data representations. Meshes, triangle strips, a list of plain polygons with UV addresses or without, with vertex normals or without, and so on. And we use one of the simplest forms that hopefully will work with most programs. But it has some caveats. And so what you do is when you go into the 3D Designer, right here under Transform, 3D Designer, you can well, here it remembers the settings I had a little bit earlier, but essentially you have the ability to set the scale here. That scale is not necessarily going to be applied to the exported file, right? The OBJ file that you can export right here, save OBJ, will be sort of the non-transformed generic mode. So it's not going to be flat. It's not going to be something like this. It's going to be probably whatever that default would be initially when you start 3D Designer the first time, something like that. But don't take that as that's it and you don't have any choices. When you take it into your 3D program, you typically have some scaling capability in X, Y, or Z. So just go into the axis representing that elevation and you can rescale it there too. What is more important is to understand that things we also export, when we export this OBJ file, we really have the resulting mesh from adding erosion. Now right here I don't have any erosion, but if I go to the maximum erosion, you see some of these creeks and canyons and erosion effects. There's also sediments, right? The sediments can be filled or they can be totally absent. So if you have some of that happening on the mesh here, that also is actually part of what you'll see in the exported mesh. Right, and if you were to not shade it, I think if you disable shading here, then you can actually kind of see what the wireframe looks like. Now it's not showing it as quads; it's just showing it as lines going across. But that's the density of the mesh. It still shows you the density of the mesh that's being exported. So let's go and export that. And it reminds me that this is potentially a large file, and I'm going to export it to a folder in which I just did that a little bit earlier, and then later I took it into Carrara, which is my favorite 3D program. But you can see that this one is 4 megabytes, 4,500 kilobytes, right? Roughly 4 megabytes. I'm going to save that again and basically give it the same name and then add something to it. Play it again, Sam, or just again, right? There you go. So that you could see the progress bar, or the little turning or circle, spinning circle. It was pretty quick. That was a fairly small file to save. Now let's have a look at it inside of a viewer like Notepad or Notepad++. I highly recommend Notepad++ for that. Because first of all, I can zoom in, right, with the thumb wheel on my mouse and control key down, I can look down. So what we have here is the OBJ file, right? In fact, let me go and open the one that I just saved a little bit earlier for this tutorial. There again, this one, right? So same thing. Well, okay, slightly different values there because I was looking at the one from Carrara, I guess, here. Maybe not. Okay, so for some reason this one is a little bit different from this one. But what you see is that the OBJ file is, we call it the simple Wavefront Wavefront. Should be Wavefront. There's a little typo there. I'll give you that. But one thing you can see is that I can't believe we just saw that first time. Wow. Okay. But essentially the data can be represented in many different ways inside of a Wavefront OBJ file. One of the ways is to first list all of the vertices and then start listing the facets that use some of these vertices, right? So you can see here somewhere there's going to be a transition where the lines here start with V, and we're getting to the last few points, last few vertices that are present throughout the mesh. There you go. And then there is a couple of lines, as empty lines as separated, just to visually aid in understanding what's going on. And then we see a facet. So here's a list of facets. Each facet has just 3 points nominated. That's point number 1. That's point number 257, and that's point number 258. So point number 1 is that very first one you see up there. Right, so it's going to use this point, and then it's going to use whatever 256 and so on is. So all of these vertices are simply a list. All of these facets are built by selecting a previously created point. That vertex is in the vertex list right here. Then we have the facets, and that's all we export. We don't have vertex normals exported. We don't have vertex UV addresses, so we don't do the baking, or we don't do saving the UV address in there. Why not? Well, it's a planar instruction projection. It's a plane projection from top down onto that. There is nothing unique about it. The UV address can easily be recreated in pretty much every 3D program. It doesn't even have to create a UV address. It just does a planar mapping. So most other programs will do that too. So you'll see here that's the only thing we have in this file. That's why it's actually a relatively small file by comparison with what others do. So what I did is I actually took that into Carrara, and here it is what it looks like. Right now you can move that around. You can scale it also, right? Use S for scale, and then you can flatten it or accentuate it a little bit, make it a little bit more pronounced. But then it's also, when you import it, you have some choices as to how you want to import it. So let me do that again. Let me move this one actually to the side, and then go to import. And this time I'm going to use that other one. That's this one I just saved out again. And OBJ import will sometimes, for some programs, like in Carrara in this case, it will give you choices, right? Do you want to have it as facet meshes, or do you want it as vertex primitives? Now I chose the default earlier, which was the vertex primitives, in which case you can actually edit every single vertex on that thing. When you represent it internally as facet meshes, that may be different. There's also some smoothing angle you can set. You can indicate whether you want some optimizations to hide the back faces. That's faces where the facet normal goes the other way, and could possibly indicate that that facet is actually not supposed to be visible unless you turn the angle and look around it from the other side. So let's go try that anyway, and see if what we can learn from that. So the facets load in here, but now if I double click that, it doesn't go into the vertex modeler, right? You would need to convert it to a modeler like the vertex modeler. There you go, to actually be able to address it that way. Let's go cancel that for now and go back to the original view. So this one here on the left I just imported. That one is imported as a mesh. This one here, come on, this one here was imported as a vertex primitive. And so when I double click that one, it actually goes into the vertex modeler. And you can see every single vertex. I have them all selected right now here. Let's click outside to deselect. So you can go and click and drag and select just a subset of that data. You could go and move around, move in. You can do some editing here at the vertex level. You can move this around. You can use the magnet tool. I don't know if that... Yeah, that affects the vertices, even the ones that are not selected. So you can hit delete. You can delete some of the vertices, such as the polygons or the edges or whatnot. So there you go. You can work at the individual vertex level if it is a vertex data representation. Right? Now, I've not used Curvy 3D much lately. But I wanted to show that that's another one you can also use, and probably load something like a vertex mesh like that as well. So let's see. I don't know if I would do that here on the mesh. Let's let's not do that. Let's not waste your time. I'm gonna go. I'm gonna do that separately and then do a tutorial. Well, okay, I'll try it here anyway. That was done with my River Canyon. That was a little bit bigger. Let's go up. 3D Designer Daily Dose. So let's go to OBJ. Where is it? There, OBJ. There. All right. So let's go this one again. And so will it be able to load that mesh? We will find out soon. See, this one takes a little bit longer. Carrara, I think, had a slightly better time loading that. 256 by 256 is not too big for Carrara. Well, Curvy 3D probably not either. I just don't know what I'm doing. Oh, there it is. It's way bigger. See, I don't know what I'm doing. There you go. Said it again. So this terrain seems like it's loaded, but I must be looking at it from the wrong side. Let me see if I can. Yeah, there you go. I need to scale it, and I'm just not that familiar with it anymore. Let me see if I do something new. Get rid of this, and of course now I'm in a slightly different conundrum here. Let's go and import that OBJ file. Because we can load 2 or 3 different actually, I don't know how many formats. Maybe just one, just the OBJ format here. Let me take that original one here. Maybe that one has something a little bit better. But at any rate, it's the data representation is really up to the application, how it utilizes what it sees in the OBJ file. It may skip the vertex normals if there were any. It may skip the UV addresses if there were any. Okay, and yeah, I definitely have a little bit of a problem here with my loading of the... Oh, there it is. There's my terrain. It's rotated a little bit. Although I should probably rotate the camera. Let's go scale it down a little bit. What's that? Is that the scale? How do I scale it? I need to scale this thing. Look. Locate backdrop. Pan. Oh, see, that's the viewing controls. I need to select the surface first. There you go. Now I can scale it down. Okay, there we go. Okay, so now I can also move it and use those handles. Love it. Okay, perfect. So we can see that works also in Curvy 3D. Right now, maybe I can scale it in one particular axis. Yeah, there you go. See, so you can make that terrain go even higher. And even scale the other way. I love it. Look at that. It can go negative scale. Okay. So anyway, that's really what this program is about, right? It's about modeling and deforming and doing some other stuff to that. But yeah, there were no UV addresses on that texture to begin with. So when we go back to not to Carrara, but to Dog Waffle, to Howler, there it is. This here had some texturing and so on and coloring applied. Now, one thing you can also do, you can export the texture there, store texture, and that creates a texture image. You can store other things too, the erosion, the lighting. There are 2 maps, one for each light source, and so on. So when you do that, you have an image here that you could possibly use. You also have it, by the way, while it's being used in Howler, it's also showing in the swap image, right? That's actually where it lives when it's being used here in the 3D view. The swap buffer, or the swap image as we now call it, is where that comes from. And you could go and paint that, right? You can paint on that and perhaps add some rocks and some noise on the grass that makes it look like grass or trees. You could paint some paths that look like roads, and all sorts of other stuff that you can have. Sediment layers like different stratified sediments, different levels of gray, different colors, some vermilion cliff colors, that sort of things. And so that texture map, that color map, is obviously something that's very interesting to export as well. And so simply save that as an OBJ, as a I don't know, let's go save it as a TIFF image or as a PNG, right? Something like that. I got the Targa here by default. Let's try PNG here, or JPEG even. if we're not picky about the quality and not lossless or whatnot. Let's go say here, export it. Oh, that's image 2. That's the texture map. Right. Texture map as a JPEG. All right, let's give it the higher quality. There you go. Okay, so now back in Carrara, for instance, we should be able to use that and map it again on it. Right? I mean, that's really the magic about, well, how can we get that texture? Well, inside this application, since the texture was not UV mapped directly on it, and even if it did, we still will have to say which texture we want to now map on it. The Wavefront OBJ file will separate the actual texture from how it gets mapped. Right? Now, we don't even map it, but if we were to map it with the UV addresses, it would still not have the texture inside of that OBJ file. The OBJ file contains just the object geometry. There is a separate file, the MTL file, that contains the object materials, and even that one will not gobble up a copy of the JPEG. It will just reference it. It will just say, oh, here's a JPEG file that's supposed to contain that texture. So inside of Carrara, and probably in most other programs, you're not quite done yet either. You're going to need to apply it a shader here, you know, and you could do something like this. You can go back out of the modeler, and I'm going to go and just focus on this one here for now. That one is in the vertex modeler. What I'm going to do is say, well, let's go and scale it down a little bit, something like that. So I want to do a projection from the top, right? And so you can go to the shader. You can apply a shader. In fact, there's some presets, and there's probably some shaders that like basic shaders that would be a good one to start from. But even if you don't, if you just start from the default shaders here and go to the texture, one fairly easy way to do that is to look for the multi-channel shader or something projection mapping, right? With the flat mapping. That's where you design you select a texture and you say you want it projected flat. Now that's one way to do it, and I never quite get it right, but let's go and choose the colors and say instead of a color we actually have a texture that we want to map on it. Alright, so which texture somebody wants to know? Well, let's go and go up one level and go find our recently saved texture map. There it is, and it finds it's a JPEG, and so here it is. Now it's not mapped properly right now, so maybe we need to rotate it, maybe we need to map it differently, and that's why when we do the flat mapping here, we need to indicate which way to go, right? So one of these is going to be the right mapping, and that's the thing about these different programs. They all have different the z-axis, the y-axis, and so on. Here we may be getting closer, but I just don't know. That's something you're going to need to experiment with. Each program is going to have slightly different effects. One thing you want to do is make sure you look at the view the right way. See how we have the terrain showing Howler going from left to right, but the texture here is not mapping that. Well, because we are projecting it in a different way. So yeah, we'll be careful here not to lose it. A bit difficult to work with that. Okay, you can also do that down here, by the way. And so if you want to see the texture here, well, that's a preview. I don't know how accurate it will be on that one, but here definitely we have the texture right now not going the right way. We have the texture, we have the elevation showing the lettering of Howler from left to right, right? But when you let go and have it rendered, you see that it's going from top down. So we need to rotate that texture. Let's go back to the texture map and see if we can. Yep, there it is. Let's rotate it. That's rotated 3 times until we got it in the right orientation. There you go. Now we've got it. Right, now we have the texturing projection mapped onto the mesh the same way as it was in Howler. All right, so that's possible. Now the next step is, can you freeze it that way? Can you bake it that way? Well, here this preview is interesting, but let's do a render and see if that looks. Yeah, that's the final one that really matters. Right? If you do this rendering in Carrara, so you can now scale it up a little bit. You can take your vantage point. There you go, something like this, and do your rendering. Okay, so we know this works. The thing is, can you then save it and then perhaps have that UV address actually texture mapped or baked into it? Yes, you can. You can go to export, and again, that will vary from program to program. If you take Curvy, if you take Carrara, Lightwave, what's out there? There's so many different 3D programs. Some of them will allow you this shade. There are a lot of programs that will allow you to export to OBJ. And in the OBJ case, I'm going to go here now, something like this, this one again, but this time I'll say Carrara. That was not the again case. Well, whatever. Carrara again. There you go. Export it to Carrara again. And there too, there are some options here. And you might want to just go with the default, but take some time to understand what some of these do. Now we may have now materials, we may have some information to export, and if we look at what that export looks like, right? So here we go back to this. There's going to be some differences here. Here, this is the one that we have in the OBJ file. This is the one that also came from us. The second attempt, right? The simple Wavefront OBJ file. Now let's have a look at the OBJ file created from the Carrara export as an example, right? Created by Carrara, 8, number of vertices. That's a comment. We don't put that in, but it's useful for humans to read. That would be actually interesting to add too. But you see that they start with the same thing here. There's a list of vertices. Right? Now, in our case, the vertices look a bit different because we just don't show the decimal part if there is none. If it's 128.00000, right, something like this, we figured we might save that, and so our number representation ends up being a little bit more compact. This one is a little bit bigger because these are actually numbers that have to be represented. I don't know what Carrara did to it, but it ended up not having that same value anymore. It shifted it, it centered it, it did something. The other thing, though, that's also interesting is that other than the vertices, there's more than just the facets. Here are the facets, but you see also vertex normals, VN. Right, so on each vertex, it also saves out what is the direction of the surface at that point at this vertex. So that's the vertex normal, not the facet normal, but the vertex normal. And then another thing is our VTs. It saves out U and V, the UV address of each vertex. Right, so it builds a list of vertex addresses here, of UV addresses per vertex. And so it has a list of vertices, a list of vertex normals, same number of those. You should see the same count if you were to look for how many VNs are there and how many Vs and how many VTs. You should see that same exact list, right? And in fact, you can do that in Notepad++. You do Control F to find something, and you say you want to see how many VTs are there. You do VT space, click count, and you see 64,736, right? And now you say, well, how many V spaces? V space. Right, 64,004. Okay, not exactly the same. Maybe there's something else, but order of magnitude should be the same. VNs. Did we do that already? No. So count there for 64,481. So essentially, we do have much more data in this export, right? And particularly the vertex textures. But then it has each of the facets, and of course, since we saved the vertex, not just the position, each facet will have a set of 3 points rather than 1 point. It's going to say, I need the vertex position, I need the vertex normal, and I need the vertex UV address from the exact same point. Right? So that's why this is basically repeating itself. But that's how OBJ will identify. And it's very powerful because you could potentially use vertex normal from a different point and vertex textures from a different point. Right? Of course, nobody really uses it that way, but it can. It's a very academic format at that. Very powerful if you start messing with that. But the thing is that when you look at this and compare our export to the one that Carrara has, Carrara does bake those vertex addresses in it, so you can use that in your game or in some other environment to bring it back in. Right now, there's a difference there too. Is you need to say, well, what file is to be mapped on it. Right, so here's a group identified. That's the G. that basically uses the name of the file to give it a group name. And then it says use material. What is that? What is use MTL? It has a default material identified somewhere. Well, that is actually identified in a materials file. And then here it says how many polygons there are about to be defined, and here they are. Here's first vertex, or the position of the first vertex, the vertex normal of the first vertex, and the UV address for the first vertex. And then the same for the second and the third. So each facet is a triangle, right? Because in this case here, we have the vertex modeler used. It's basically building triangles. That's how it came in from the original. That could be rearranged in some of the vertex editing tools. Sometimes you have tools to turn it into a quad mesh or into triangle strips and that sort of things. But here the export is very similar to what we had. It's one triangle at a time, except that each triangle is defined not just with the vertex position for the triangle, but also with the vertex texture and the vertex normal, right? So this one is a little bit more elaborate. It also means that it's going to take much more disk space. If you save the file, if you look at the file sizes, here you go. Compare the one we exported initially from Howler with just the vertex positions. That one's 4 megabytes, 4.5. The one that I re-exported from Carrara, 12, 3 times as much. Not surprised, right? I mean, vertex normals are just the same amount of data as vertex positions. It's X, Y, Z. So it's going to go from 4.5 to about 9 or 8 or something like that. And then vertex normals, I mean, vertex addresses, I mean, texture addresses are 2 components, U and V, right? The others have X, Y, Z, so, or are normals X, Y, Z, I, J, K. Those are 3 components, but there's going to be another 60% increase. So from 4.5 to 9, it should go up another 3. It should be about 12 megabytes. Ta-da! 12.6. Not surprised at all, right? So the same thing when I exported the Carrara again, just 5 minutes ago. There you go. Right, so there are a lot of things you can do with it. Even though it doesn't have the UV addresses when it comes out from Carrara. When it comes out from Dogwaffle, from Howler, you can usually find your way to put those UV addresses back on, because it is a planar projection mapping that we applied here. And so that's just what I wanted to kind of cover. I know, took a few words to say it. Anyway, thanks for watching, thanks for howling, and for waffling.